Okay, in this video we will see how to solve a differential equation that involves a delta Dirac function. Useful formulas are these. The Laplace transform of the delta Dirac function at a is just e to the negative as. Remember that this function can be viewed like a function that is a big number near a, and the area under the graph is 1. It's 0 everywhere else, and it's used to represent something like when you hit a ball with a bat, then a big force is made at that particular time. And then, for example, since you can hit a ball harder, for example, you will have a difference between this function and this function. These two functions represent that the ball was hit at t equal 5 seconds, and this was hit with a force of 3 newtons, and this was hit with a force of 7 newtons. That's like the physical interpretation of the delta Dirac function. But for the sake of solving differential equations that involve the Laplace transform, the only thing that you need to know is that the Laplace transform of that function is e to the negative as. Let's solve this differential equation. The Laplace transform of the derivative is s times Laplace transform of y minus y of 0 minus 5 minus the Laplace transform of y equal the Laplace transform of 2 over s plus Laplace transform of 3t is 3 over s squared plus 5 times the Laplace transform of the delta Dirac with a equal 3 is e to the negative 3s and minus 7 e to the negative 5s. Then the next step, as always, is to solve for the Laplace transform of y. Here we have that s minus 1 Laplace transform of y is equal to 5 plus 2s plus 3s squared plus 5 e to the negative 3s minus 7 e to the negative 5s. And then the Laplace transform of y is equal to, let's combine these three, it would be 5s squared plus 2s plus 3 over s squared. The common denominator is s squared here, and we are dividing by s minus 1, and plus 5 over s minus 1 e to the negative 3s minus 7 over s minus 1 e to the negative 5s. Essentially, we need to compute 3 Laplace transform inverses. This one is relatively easy. This one is the Laplace transform of 5 e to the t. This one is just the Laplace transform of 7 e to the t. And for this one, we need to do partial fractions. Let's do that. Then we write 5s squared plus 2s plus 3 over s minus 1 s squared. In this case, the partial fraction decomposition will be a over s plus b over s squared plus c over s minus 1. We make sure that to have the same common denominator. This denominator should be equal to this, and then this is just a times what is missing, s to be s squared times s minus 1, and an s minus 1, plus b, what is missing, s squared to be s squared times s minus 1, and s minus 1, plus c times s squared. Then when we compare the coefficients, we get that the coefficient of s squared would be a plus c, and we want this to be 5. The coefficient of s is negative a plus b, negative a plus b, and this should be equal to 2, and the constant coefficient is negative b, and we want this to be equal 3. Then b must be negative 3. If b is negative 3, a should be negative 5, and if a is negative 5, c should be 10. That means that this expression is just negative 5 over s minus 3 over s squared plus 10 over s minus 1. And then I can continue saying that this is the Laplace transform of negative 5 minus 3t plus 10 times e to the t plus e to the negative 3s times the Laplace transform of 5e to the t minus 7 times minus e to the negative 5s Laplace transform of 7 times e to the t. Then in the answer we will see this function negative 5 minus 3t plus 10 e to the t plus, and this part generates a function u3 of t times, and then anytime I see that t here, I change it with t minus 3. Then I get times 5 times e to the t times t is changed with t minus 3, and then minus u5 of t, this part is replaced with u5 of t, times, and anytime I see that t, I have to replace it with t minus 5. Then I get 7 times e times t minus 5. Then this is the answer for this differential equation.